So let's start on page 138. Let's look at some solving that are a little bit harder, but you're still just solving for x. So right here, I'm going to talk you through example B, and then we will do one as an example. So let's say we have 2, and then in parentheses, x minus 3 squared minus 5 equals 0. So really, we're just going to solve for x in this process. So you move the constant over, so you'd add 5 to both sides. Then you would divide by the number in front, that 2. So don't think you distribute the 2. That does not happen. You just divide both sides by 2 so that we get 5 over 2. Now notice we have that exponent. We need to do the inverse of a quadratic, which would be a square root. So we take the square root of both sides. That's how we get the square root of 5 divided by square root of 2. For our purposes, we are going to just write this as x minus 3 equals plus or minus. We'll just write this as one big square root, 5 over 2. Now we add 3 to both sides because our goal is to get x by itself. So when we add 3, we just write this as x equals 3, and then we put the plus or minus, then that big square root. Later, we will talk about what's called rationalizing the denominator. That's not today, but we could rationalize this, and that would give us the square root of 10 over 2. That will be a future lesson. So for us, we will just stop here for today. So let's do an example. So in this example A, first thing we need to do is to add 49 to both sides. Get rid of that constant. So we have 4, and then we still have everything in the parentheses, squared, but now this equals 49. Now we can undo that multiplication of 4. The inverse of multiplication is division, so we divide both sides by 4. So we have x plus 5 squared. The whole thing is still in parentheses, being squared. We have 49 over 4. You're welcome to simplify if it does simplify. In this case, it doesn't. So I'm just going to leave it as 49 over 4. Now, we need to do the inverse of this quadratic, inverse of that exponent of 2, which is the square root. So that means we're taking the square root of that entire fraction, square root of 49 and square root of 4. So we have x plus 5, but this equals plus or minus. Anytime we have square roots, just go ahead and put plus or minus right in front of it. So we have this square root of 49. Well, that's a perfect square, 7. Square root of 4, that's also a perfect square. So I'm just going to write 4. Notice when you take the perfect square, the square root goes away. When you take the square root goes away. So we've almost solved this problem. All we have to do now is just move over this positive 5 so we can get x by itself. So we're going to subtract 5 on both sides. So our final answer is x equals, just go and put minus 5, then put the plus or minus 7 over 4. So this really represents two values. It represents negative 5 plus 7 over 4 and negative 5 minus 7 over 4, which negative 5 plus 7 over 4 is approximately negative 3 over 2, actually equals exactly negative 3 over 2. And negative 5 minus 7 over 4, that equals negative 17 over 2. But you could have just stopped and gotten your answer here. So let's try another example. Let's skip down to problem D right here, where we'll have an imaginary. So it's the same process. Move over the constant. So we're going to subtract 25. So we have, I'm going to put it over here, 4, then x plus 7 squared equals negative 25. Then similar to the last problem, divide by the number in front. So we're dividing by 4, doing the inverse. So we have that x plus 7 quantity squared equals negative 25 over 4. Now we can do the inverse of a quadratic, which is a square root, basically the inverse of that power of 2. So we can take the square root of both sides. So that means we're taking the square root of this negative 25 and the square root of 4. Notice the negative only goes with one of the values. I usually just put it with the numerator. So we have x plus 7 equals, we have a square root, so we know there has to be a plus or minus. So right here, this numerator, that numerator is square root of negative 25. Well, remember from earlier, anytime you have a negative, that means there's an imaginary. So this is really square root of negative 1 times square root of 25. Square root of negative 1 is I. Square root of 25 is just 5. So for notation, we normally just write this as 5i. Okay, so our numerator is 5i. Denominator is square root of 4, just square root of positive 4, which is a perfect square, which is 4. So we are almost done. Right here, we just need to subtract that 7 on both sides. So we get x equals, put negative 7, and then do plus or minus 5i over 4. That's as far as you can go. Now, an alternate way you could write this would be plus or minus 5i over 4, and then put the minus 7. But it's kind of odd to have that plus or minus out in front when you have that negative 7 in the end of the equation. So it just looks a little bit better if you put the number in front, then plus or minus, and then the other number. So just kind of put that plus or minus in the middle. It just kind of looks more balanced. Okay, so the next thing we're going to quickly look at is completing the square. You've already watched a review video of this, but let's just do one quick example, maybe two, and then you'll just practice. So it's on page 139. So completing the square is another method for solving these quadratics. So let's just talk through this first example. So let's say you have 2x squared plus 12x plus 5. Now you could, if you remember that bottoms-up method, you could use that bottoms-up method here. So this is just another strategy to have in your math tool belt. So what we do is if you want to do completing the square, so completing the square is where you move over, you divide everything by that leading coefficient. So if it's a 2 out in front, everything gets divided by 2. So basically, you just move that 2, the 2 goes away, the 12 gets divided by 2, gets 6, the 5 gets divided by 2. Just leave that as 5 over 2. Now you move over this constant. So we only want variables on one side, and we move the constant to the other. So we have to subtract it. So this is the kind of steps for completing the square. You need to take that b term, which the video talked about. It was that middle term, so b is 6. So the process is you always divide it by 2, and then you square it. So 6 divided by 2, well, that's 3. 3 squared is 9. So that 9 is what gets added to both sides of the equation, because what you do on one side, you must do on the other. It's like a seesaw, it has to balance. Balancing scale. So by doing that, it helps because what we get right here is a perfect square trinomial. By doing this step, divide by 2 and squaring, we will always get a perfect square trinomial as the result. So you do this every time. Divide by 2, square. So x squared plus 6x plus 9, if you factor that, you will see that the factors are an x plus 3 and an x plus 3. Or more simply, you can just put x plus 3 squared. And now we can use our solving skills that we have practiced to solve this. So we can take the square root, try to undo that exponent, so take the square root of both sides. So now we have x plus 3 equals plus or minus square root of 13 over 2. For our purposes, we're going to leave this right here, like the square root of 13 over 2. Tomorrow we may talk about rationalizing the denominator, but for right now, all we would need to do after this step is subtract 3 on both sides. So now x equals negative 3 plus or minus, and put one big square root, 13 over 2. That's as far as we will go for today. So let's do one more example that's not worked for you in the book and that has an imaginary term, and then we'll be done. So the next page, page 140, we're going to look at this example B problem. So first thing is to divide by that leading coefficient. So notice that number in front is a 2. So everything gets divided by 2, even the 0, even though that doesn't do anything. So that cancels. So we have x squared minus 4 divided by 2 is 2x plus 7 over 2. Just leave that as a fraction. That equals 0, because notice 0 divided by 2 is just 0. So now we can move the constant over. So notice we will add that subtract negative 7 over 2 to the other side. Now we do completing the square. So this negative 2, we divide it by 2, then we square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I add 1 on both sides. So then we have a perfect square trinomial that we then solve in our final.